Alright, so we're in Journal 16 here, and the question for our bell work today is to find the area of a circle that has a radius of 4. Now, I think we've all encountered this question before in our geometry classes. I need to find the area of a circle given that the radius is 4. So first off, what is the formula for the area of a circle? So this is where, you're more than welcome to Google it. But in this case, I will give that to you because we found it in class. So the area of a circle is pi r squared. Pi times r squared. So in this case, all this formula needs is a radius, which is what we have. So I'm going to plug this 4 into r and see what I get. So that would be pi parentheses 4 squared. And so if I were to do my exponent first, because order of operations, so 4 squared is 16. So pi times 16 is, 16 pi. You don't need to plug this into the calculator. You can use pi, you can just multiply pi and treat it like a variable. So it's just 16 pi. And it's also asking, in the second question, what would be 1/4 of the circle's area? So it's asking if I had this circle, so this circle is 16 pi as the area. So let me draw us a circle. That might be more helpful. So here's our circle, and the entire circle is, the area is 16 pi. Well, it just wants to know what would 1/4 of the cut or the portion be. So it wants to know what is this part. What is this area? If you just wanted 1/4 of it. So in that case, couldn't I just take my entire area amount, 16 pi, and divide it by 4, right? Yeah, I could do that. So you could just take 16 pi divided by 4 and get your answer. Another way you can do this in math is multiply it by the fraction that it's proportioned into. So if you have 16 pi, the whole, and you multiply it by 1/4, because this piece right here is 1/4, then you should also get your area for that piece. Notice how when you multiply this, it's a fraction times a whole number, and you can always make a whole number into a fraction if you put it over 1. And if you multiply straight across, 16 pi times 1 is 16 pi over 1 times 4, which is 4. And notice just a moment here that this here is just saying 16 pi divided by 4. So it's the same problem like we said the first time around. So we will work this out. We can reduce this. 16 divided by 4 is 4. And then you still have a pi. And so this is going to be 14 pi. Okay. And so it looks like the area of this piece right here is 4 pi. All right, so the reason why I brought up this problem is that we're going to be looking at area of a circle, and we're going to be looking at the length of something called an arc, and I'll explain that here in the next slide. So let's talk about arc length first. So arc length is basically if you have a piece of circle. So let's say I have a circle here. Sorry, my circles are awful drawing. Let me do that one more time. Let me get my circle tool. How about that? There. And so if I were to move this around just a little bit. So if I have a circle, and let's say that this here is the center. And if I want to know the arc length, well, that just means that if I were to cut this proportion here and call this some sort of angle, then the arc length would be this region right here. So that would be my arc length. Maybe I'll do that in pink so that way we can see it better. Yeah. So this is my arc length, which we represent by S. So the arc length is basically a length on the circle in a certain angle of the circle. So in this case, this formula here, let's just go over it. We need to know the radius, right? So the radius would be technically this piece right here. the radius. It's the distance from the center to the outside of the circle. So these pieces right here would be the radius, these two lengths. So you need the radius, you need the angle of measure, but here's the thing, this angle has to be in radians. Has to be in radians to use this formula. If it's not in radians, you're not going to get the correct answer. So that meaning that you can't use degrees. The reason why it needs to be in radians is because this is actually multiplying by a proportion. Radians are proportions. Just like how we saw in the last slide, you needed to multiply by a proportion so that way you can get the certain proportion of length that you desire. And so just make sure your angle is in radians. The S represents arc length. Okay, I think we're ready to use this formula. So we need radius and the arc length. So in this story problem here, or this word problem, it's asking for, it has a circle that has a radius of 18.2. And it says to find the arc length. So we're looking for the arc length given the following angle. So it looks like they give us an angle here. And so our radius, like they said, is 18.20. And so it looks like we have all the ingredients we need to plug this into the formula. So I'm just going to plug it in. So S is equal to 3 pi over 8 times 18.20. And if I multiply this through, I would get, I'm going to round that to 2 decimal places. It looks like it would be 21.44. And so it looks like my arc length is this amount. All right, let's try another one here. So this one gives us the angle, but it's in degrees, right? So that's the unfortunate part. We can't use things that are in degrees, so we're going to have to convert it. So we're going to convert this by using the radians of conversions to, so we're going to convert degrees to radians. So what we've learned before is you take your degree, you multiply it by the proportion of, so you want degree in the bottom, so 180 in the bottom, and pi in the top. Remember, when you do this, this allows you to cancel the degree units because they're diagonal from each other. So if you multiply this straight across, you can always put, 144 over 1 and multiply this straight across. So 144 times pi is 144 pi. 180 times 1 is 180. If you were to simplify this, just take, 144 divided by 180. And you can get a decimal number, or if you want to keep this as a fraction, simplify the fraction. You can do that too. So let's see, what would be the best case here? I'm trying to think of. You know what? I'm just going to keep dividing it by 2 since I don't have a calculator with me. So 144 divided by 2 is let me do that in a calculator then. 72. And this would be 90. If you take 72 divided by 2 again, so this is what I have right now. If you divide it by another 2, you would get 31. 90 divided by 2 is 45. And then I can keep my answer like this. Give me 1 sec to double check my values here. Oh wait, hang on, I think I messed up. Let me start over again. Sorry guys, it is early in the morning for me. So I think what happened was, so I have 144 multiplied by pi, and then 180. If I take 144 divided by 2, I get 72. 180 divided by 2 is 90. 71 divided by 2. Oh, okay. I think I know what I messed up on. Let me just double check. So I think what I'm going to do instead to make this easier, I'm just going to take 144 and divide it by 180 in the calculator. 144 divided by 180 gives me 0.8. And then I would put a pi next to it since there's a pi. That might just be easier. Okay, so now that I have my degree, my angle, that's in radians, I can now plug this into my formula here. So I'm going to plug that in. We would have the radius, which was 18.2 times my angle, so 0.8 pi. If you plug that into the calculator, you're going to get 45.74 if you round to 2 decimal places. And that's it. So basically, in order to use this formula, you need the angle in radians and the radius. All right, now we're going to do a few practice problems with them from the homework. Okay, so in here it says find the, it gives you a circle and you have to find a certain part of the formula in the previous slide. So S times the radius times the angle. So in this first one here, you need to find the exact length of the arc. So if you're looking for the length of the arc, you're looking for S is what you're needing to find. So it looks like in this circle, we are given the angle, which is 5 pi over 4, and the radius, which is 16, it seems like. So these two pieces I can plug into my formula to get my arc length. So I have the radius being 16 times 5 pi over 4. So if you were to work this out, you could do this by hand because you need to find the exact value. So I don't recommend the calculator or else you're going to get some decimals. So to work this out, I could put 16 over 1 to multiply these two. 16 times 5 is 80 pi over 1 times 4, which is 4. If you divide 80 with 4, you get 20 pi. Yep, looks like it. So all I did was take 80 divided by 4 and then put the pi next to it since there's a pi in the numerator. So we get 20 pi for this arc length, it seems like. The next one is asking to find the radius. So if we're finding the radius here of this circle, we're trying to find, this length here. So we're given, it looks like the angle is pi over 2. The arc length looks like it's 3 pi, and we need to find the radius. So to do that, let's plug into the formula what we know. We know the arc length, and we know the angle. So this would be 3 pi equals r times pi over 2. Well, in this case here, I want to solve for r. So because this is pi over 2 multiplying this r, can I just divide by pi over 2 to cancel? But then I have to divide by pi over 2 on this side. Okay, so let's try that out. So 3 pi divided by pi over 2, all I can do is just take 3 pi, and this here is a fraction, so I can flip it when I multiply by the reciprocal. So you do that when you're dividing. So that would be 2 over pi. And if you were to multiply straight across, remember you can always treat this to be over 1. And then you can cancel out the pi's because they're diagonal. So it looks like if you multiply straight across, 3 times 2 gives me 6. And then the bottom here, by the way, when you cancel out things, it just becomes a 1. So this is really just 1 times 1, which is over 1. So let's see if I can make that smaller. There we go. So it looks like r is equal to 6. And so our radius here is 6. Last one here, we're looking for the measure of the central angle. So this time we're looking for the angle, but we have the arc length, which is 20, and our radius here is 10. So I'm going to plug in these two variables into the formula. And so that's going to look like 20 equals 10 times theta, because I don't know what theta is. And this problem is probably a lot easier. All I have to do is divide by 10 to both sides to cancel that out. So I set theta. And so it looks like our angle here is 20 divided by 10, which is 2. And our theta here is 2. The angle is 2. Keep in mind that this angle is in radians, so it doesn't mean that's like 2 degrees. It's like 2 radians. Okay, so now that we've gotten kind of a feel of using this formula, the arc length formula, let's talk about finding the area of these portion of the circle. So finding an area of a slice of a circle is what we call the area of a sector. This portion right here is a sector of the circle. Okay, so here I have the formula for the sector of a circle. So that's if you want to find like a portion within the circle, a piece from the circle. And so how you would find this is just very similar to the area formula of a circle. The R represents the radius and you're squaring it. So this is your radius. And then this theta here is your angle, but it, again, like this, the arc length, it needs to be, meant to write angle, needs to be in radians. So make sure it's in radians. So let's see here. In this problem, we are going to try to find the area of this following sector. So we have, let's write down what we have. We have the radius, and we have the, it looks like the arc length, right? So we have the radius, which is 6. I don't know what the angle is, unfortunately, but I actually have the arc length, which is this 2 pi. Well, that's not good, because if I plug in the radius, I can't find the area of the sector because I don't have the angle, unfortunately. So I can't use this formula yet. Instead, I have to go back and use the arc length formula first. So the arc length formula is, in the last one, radius times theta. And so I know that I have 2 pi for my arc length, and the radius here is 6, so I have to find my theta. Well, that's not too hard. Just have to divide by 6 to cancel out, and so then I have a theta here. And then if I were to reduce this 2 over 6, what divides into 2 and 6? Well, that is going to be 2. So 2 divides into 2 1 time, 2 divides into 6 3 times. So this is really 1 pi over 3, or just 1 times pi is pi over 3. So I have my angle now in radians, and so now I can find my area. So if I were to find the area, I have 1/2 following the formula. The radius is 6 squared, and then I have the theta, which is pi over 3. And so if I were to do order of operation, I would have to square it first. So 6 squared is 36. And it's all multiplication here, so I just like to do it left to right, because that's how we read left to right. So math is the same way. 1/2 times 36. If you don't know how to do that, just take half of 36, or you could just put 36 over 1 and multiply straight across. So 36 over 2 times pi over 3. 36 divided by 2 is 18. And then I have to multiply this by pi over 3. So what I can do is put this 18 over 1. And if I were to multiply this out, I would get 18 pi over 3. If I divide 18 by 3, To reduce this, I get 6 pi. So it looks like here my area is 6 pi. All right, that was a bit of work. So here's the thing. We had to find the arc, use the arc length to help us find the angle, and then we could plug it into the formula to find our area of the sector. So this piece right here is 6 pi. Excuse me. Last one here, it's the same thing. I'm not given the angle, but I am given the radius, which is 10. The angle here, I don't know. But the arc length, it looks like it is 15 pi. And so in my case, if I had to solve this out, I need to start by finding the angle. So just like before, I'm going to start by using this formula and plug in everything I know. So I have 15 pi for the arc length. The radius here is 10, and I don't know my angle. So I have to divide both sides by 10. That cancels. Theta comes down. Now 15 and 10 can be reduced if you divide by 5. 15 divided by 5 is 3. 10 divided by 5 is 2. So this is really 3 pi over 2. And so now I have my angle. So the next thing I could do is plug this into my formula here. So my formula is the area 1/2 times the radius. So the radius here was 10, square that, times my angle, which is 3 pi over 2. So if I were to multiply this, well, let's square this first. 10 squared is 100. So this is really 100 times 3 pi over 2. So if you take 1/2 of 100, it's 50. But if you don't want to do the quick way, you can always put this over 1. 1 times 100 is 100. 2 times 1 for the bottom is 2. And notice that it's still 100 divided by 2. 100 divided by 2 is 50 times 3 pi over 2. So if you were to work this out and multiply this straight across because it's a fraction, 50 times 3 is 150 pi. 1 times 2 in the bottom is 2. 150 divided by 2 is, it's a nice number. I think it's 75 pi. And there we go. We have found the area of this sector right here. And that's it for this journal. I hope this helps out.